There are two aspects to code quality that you can automate: testing and linting. Hey everyone, Steve Perry here. Let's talk about testing and linting. To automate testing, you need a test framework, an assertion library if the framework doesn't provide one, a test doubles library, again if the framework doesn't provide one, and a code coverage utility. To automate linting, you need a linter with Parser and configuration rules to apply to your code. I'll talk about all of that in this video. All of the code examples you'll see in the video are available in GitHub, and a link to the GitHub repo is in the video description. Let's get started. Mocha.js, or Mocha, is one of the most popular test frameworks for JavaScript. But why use a test framework at all? Using a test framework like Mocha gives you at least 3 benefits: an API for writing tests, test discovery and execution, and a well-defined test lifecycle that you can hook into. The Mocha API is very straightforward. The describe function is used to create test groups, sometimes called test suites, and the it function is used to create the actual test cases. To run this Mocha test, open a terminal window, navigate to the Unit 9 directory, and run Mocha and specify the name of the test. Test discovery and execution is another benefit a framework like Mocha provides. To run all tests in a directory, you start Mocha and tell it the directory where the tests reside, and it runs every test it finds. A test framework should have a well-defined test lifecycle, along with hooks that you can use to do setup and teardown before and after tests run. Mocha defines several hooks in its test lifecycle: before all tests, after all tests, before each test, and after each test. That covers the test framework. Next, I'll show you test assertions using Chai.js. A test framework isn't much good unless it provides an API that lets you verify that your program's expected and actual behavior match. The functions in such an API are called assertions. Chai.js, or Chai, is a very popular assertion library for JavaScript. It supports test-driven development style assertions and behavior-driven development style assertions. I think the BDD style assertions are easier to read, so those are the ones I've chosen for this course. Here you can see a Chai BDD style assertion in action. You pass the condition to be checked as an argument to the expect function, then use chaining to write the assertion like you see here. To run this test, flip over to the same terminal window from earlier, run Mocha, and specify the name of the test. And that's Chai. Again, all the examples you see in this video are available in GitHub. Next up, let's talk about Sinon and test doubles. Generically speaking, a test double is an object that stands in for another object, like a stunt double. There are several types of such objects, like spies, mocks, and stubs. Sinon.js, or Sinon, provides functions you can use to create all of these, and they plug right into Mocha. To create a spy within a Mocha test case, you call Sinon.spy and pass it the name of the function you want to spy on. In this case, it's console.log. Make the invocation to console.log, passing it the message, "You will see this line of output in the test report." Then assert that the message was passed to console.log. To run this, flip over to the terminal window and run Mocha test/example3.js. Notice the output of console.log is interleaved in the test report. Let's get rid of that. To do that, we'll use a stub. To create a stub within a Mocha test case, you call Sinon.stub, passing it the name of the function to replace, console.log. Invoke console.log with the message. Make sure to replace the actual console.log by calling restore, or the test report won't look right. Then make the assertion as before. To run this from the terminal window, invoke Mocha test/example4.js. And there's the test report. This time without the actual message from console.log because it was stubbed out. That was a look at Sinon. Again, all of the examples you see in the video are available in GitHub. Next up, code coverage with Istanbul. When testing, you have the code under test. Let's call that the target. And you have the test cases you want to run against the target. The idea behind code coverage is that when you run your tests, the coverage tool will tell you what percentage of lines of executable code were run during the test. The idea being that the more lines of code are run during the test, the better code coverage you have. One of the most popular tools for JavaScript test coverage is Istanbul. Istanbul instruments your JavaScript code on the fly when it runs, then invokes your test framework so it can tell how much of your code was executed when your tests run. To run Istanbul's command line interface called nyc, run it in the test script and tell nyc what framework to invoke, Mocha in this case. When it finishes running, it prints a test report at the end showing the coverage. Looks good to me. Static code analysis is a technique that can spot potential errors in your code. Running a static analysis tool against your code is called linting, and the tool itself is called a linter. One of the most popular linters for JavaScript code is ESLint. One of the configurations you'll use in Unit 9 is ESLint config Google. To configure the linter, you'll go into your package.json and add a few scripts. The lint script runs ESLint and tells it to lint everything in the current directory recursively through the entire project. The lint-fix target tells ESLint to fix any errors it can fix automatically. This includes spaces after a single line comment, for example. When ESLint notices this, it fails the test run with an error. No worries though, we can run the lint-fix script. ESLint fixes the error automatically, and the test run completes successfully. You can configure other aspects of ESLint, like what configurations it uses, such as ESLint:recommended and ESLint config Google. Parser options like the ECMA script version to use, ES6 in this case, rules you want to override like the max length. Here you can see I've overridden the default of 80 and made it 120. You can also tell ESLint to ignore certain directories you don't want it to lint, like node modules. ESLint is highly configurable, so make sure and check out the documentation if you want to learn more. And there you have it, code quality through testing and linting. Again, all of the examples you see in the video are available in GitHub, and a link to the repo is in the video description. And be sure to check out the full Node.js course available at IBM Code. A link to the course is also in the video description. I hope you enjoyed the video. I'm Steve Perry. Thanks for watching, and I'll see you next time. So long.